All right, so I think I'm recording. Let's take a look at, we've been looking at our semester review problems, and here in problem number 20, they're asking us to use two old functions to build a new function. And the naming convention is a little bit new to you and different. You know, if you have two functions, you probably suspected that you could create a new function by adding them, subtracting them, multiplying them, dividing them. You may not have been aware that about function composition, but it was probably no big surprise that you could add two functions to get a new function. The notation here, they're just giving this a name that tells us, they could have called it H, but calling it f plus g allows us to recognize that they took the function f and added the function g. That's the advantage of naming it like that, is to know how it was built and where it came from. So if f is 3 over x minus 4 and g is 2x over x minus 2, these are two fractions, but they have different denominators. So in algebra, it's a common technique to multiply by the number 1, but to write 1, I always jokingly say in disguise that we can write the number 1 as a fraction. And the reason we would do that here is so that we could get a common denominator. We see that in this first fraction it has a factor of x minus 4, but it doesn't have a factor of x minus 2. And over here it has, this one has x minus 2, but it doesn't have the x minus 4 that the first fraction did. Well, we can't just come in and change it arbitrarily, but we can come in and multiply it by the number 1. So what's going to happen is that it retains its same value on the number line, but visually it looks different. But because now we're going to have a common denominator, it allows us to add these two fractions together. So let's do that. With a common denominator, you don't do anything to the denominators. You just, in multiplication, you can write this in any order. And I'm actually not going to take the time to multiply them together, because we've seen in Skill Packet 4 when we had rational functions that you get a lot of information from these expressions being in factored form versus a standard form. And it doesn't really say that I have to multiply them together. So I'm going to leave it just like that as a product. Now, I am going to simplify the numerator. I'm going to take this 3 and distribute it to both terms. I've got 3x minus 6. And here, this 2x, I'm going to distribute it to both terms. And I've got 2x squared minus 4x. So we'll clean that numerator up a little bit. And if it's multiple choice, you're just simply working on getting your answer to match one of the choices. So we've got 2x squared minus x minus 6 all over x minus 2 and x minus 4. So there is our final answer for part A. Let's take a look at part B. I think I'll need these two functions. Yeah. So now it's the same idea, except instead of adding the functions, we're going to subtract them. So we've got f of x minus g of x. So let's use some of our previous work. If the only difference between this problem and the last problem was that our operation last time was addition, well, this time it's subtraction. So we'll use our previous work. Let's distribute the 3 and we get 3x minus 6. Now this time with the minus, I need to subtract everything, not just the first or favorite term. So I've got 2x squared minus 4x. See, last time that was addition and the parenthesis wasn't important at all, but this time it is. So I have negative 2x squared. The double negative here becomes positive, and I've got 7x minus 6 all over x minus 2 and x minus 4. So there's my answer for part B. Let's take along our functions for this next part, part C. So again, they could have called this anything, but they called it f over g because they're telling us how this function was built. And the numerator is f. Well, f itself is a fraction, and the denominator is this fraction 2x over x minus 2. So they would definitely expect us to simplify a complex fraction. And it's not terrible if you remember what to do. I'm going to leave the numerator alone, the 3 over x minus 4, but instead of dividing by this fraction, I'm going to multiply by the reciprocal of that fraction. So if I flip this 2x over x minus 2, and now I don't see anything that would cancel. So to multiply fractions is pretty easy. You just go straight across the numerator, straight across to the denominator. So I have 3 times x minus 2. I'll write the 2x first. 2x times x minus 4. And again, I don't see anything that cancels and stuff. So, and I'm not going to write my restrictions over here. I'm just going to say that's my new function. I guess technically I should write restrictions, but we didn't really truly emphasize that. So that comes about if we're finding the domain, because we did emphasize how to find the domain, and that's what those restrictions are. And we do the domain in a later question. So there's my answer for part C. Does this have a part D? Yeah, okay, function composition. So with this function composition, what we're doing is you start with the second function, or if it's written in this notation with the inside function, you're taking the function g and you're plugging it into the function f. So I always describe it as an assembly line, that you input some number from the domain into g, and out of g, the output of g now becomes the input for f. Alright, so let's do this function composition for this problem. When we input gx into g, this formula tells us that what comes out of g is it'll 2x over x minus 2. So now if we input that into f, what comes out of f? Well, what does the function f do to the input? Let's think about that for a second. F will take whatever input you give it, and this time we're giving it a fraction, a variable fraction, and f will always create a fraction with 3 in the numerator, and in the denominator it'll take that input and subtract 4 from it. So whatever the input is, we see it down here in the denominator, and then take 4 away from it. Alright, so let's do that, and then we'll have our final answer. So for us, this input is this crazy 2x over x minus 2. So we've got 3, and inside here where it says input, we've got this 2x over x minus 2. So they would expect us to simplify a complex fraction. And so again, we're going to use a technique of multiplying this by the number 1. And we're going to look at this fraction in the denominator of this fraction of x minus 2. And I'm going to write the number 1 as x minus 2 over x minus 2. So when I multiply fractions together, I just multiply straight across the numerator and denominator. So this numerator is extremely easy to figure out. It's simply 3 times this binomial. Now, it takes a little bit of time and effort to figure out when I take x minus 2 and distribute it to both terms what I get. When multiplication distributes over the subtraction, so first I multiply the first term by x minus 2, and then I multiply the second term. So I have this 2x over x minus 2, and then I've got this 4. Well, both of these get multiplied by this x minus 2. So when I go to take x minus 2 and distribute it over the subtraction to this first term, the x minus 2's cancel, and in that first term, I simply have 2x. Then it's minus, and it's the second term, 4 times the quantity, x minus 2. Well, I may as well distribute that now. No, well, let's see. I'll just write it like this so you can see exactly what's going on. Let me erase this, and let's simplify this a little bit. Let's distribute the 3, and we get 3x minus 6. Let's distribute the negative 4. We've got 2x minus 4x plus 8, and 3x minus 6. 2x take away 4x is a negative 2x plus 8. So I don't see all even numbers or numbers that I can reduce. I can factor out a 3, I can factor out a negative 2, but nothing's going to cancel, so I'm not going to really gain anything from that unless my solutions are written like this, because see, this isn't going to, nothing is common, so nothing is going to cancel. I don't get an x minus 2 and then another x minus 2. So either one of these is my final answer. It just kind of depends on if it's a multiple choice problem. If it's not, then you can give whichever one you want as your final answer. So I think that's it for this problem. Yeah. So I hope that helps, and I'll talk to you later.